material all right, or is it overwhelming, or how is it for you guys?
A lot.
Yeah, it's a lot.
Working through it.
Okay, talk to me. Is it well, it is kind of crazy in the beginning, right? Because it's the small stuff, which I wasn't actually able to read the tablets yet. I've been crazy catching up. My dog broke his toenails, so
Yeah.
I probably told already, so it's been all over crazy. Um, in terms of a lot, is it like are there like, roadblocks a lot, or things that are like too challenging, or feel too redundant, or what are you guys? How is that going? Are you guys all right with all of that, or talk to me a little bit? You can.
Oh, well, I mean, for me, and I, I am a science major.
Hmm.
It's nice because I can try and recall what I learned from many years ago, but also because I'm working, you know, it's just a lot. It's a lot of material. It is manageable. Um, with life, family and work. But yeah, it's a lot.
But it's man. Okay. No, no, no. I don't want to minimize that at all. I mean, I'm actually glad because I'm always afraid I don't do deep enough studies.
That's
so,
where I'm at. Yeah.
so I'm like, I'm happy because, and actually, that has been my experience. Like a lot of what you learn in this class, carries on into a Bio 20AB or Bio 2 very heavily. It's just you may go a little bit more detail in looking at slides, for example, but the structure and the verbology is already very much there because I just took the class a couple of years ago to just sort of check on that part. So, and of course, I also try to integrate it with real life sort of stuff like the food label analysis. Did you guys enjoy that, or was that like, what the hell am I doing here?
I liked it. I actually made better food choices yesterday when I went out with my girlfriend.
There you go. That's the whole point. Huh? So it was, because it's actually very helpful to learn that way if you really look at what it means, and hopefully that makes a lot of what it is busy and it's a lot, but makes it relevant and applicable, hopefully.
Yeah.
And it seems like it does that, right? At least for some of you guys.
Mhm.
And so that's good. And I'll actually go to check in at the discussion on that food label a little bit later. Some people started already, so we'll get into that. So in terms of the material, this was chemistry week, so that's usually kind of like, oh God, how was that for you guys? Are you guys all right with that? Questions about that? So you all superstars in chemistry. That's perfect. So
No, no.
well, the thing is, you don't need that. That's where you have the. I tried to make it a level, where we know about atoms, we know about bonds. That is like, why is an ion an ion, and why is a carbohydrate like a protein is different than an a sodium ion, for example. So it's body relevant, right? So we need to have a little bit of that framework. And then the other part, of course, is the organic part where we talk about, that's where the food label comes in, where we talk about carbohydrates and proteins and fats and nucleotides. And then later on, the ATP. These are all molecules that we have in our body. And as soon as they have carbon in it, we sort of consider them organic molecules. I hope you got that drift of the lecture there. Um, is there like real blocks where you go like, this don't make no sense at all to me, or is pretty much all right in that level?
I think it's pretty much all right.
Okay, good. Then because a lot of that is repetition for a lot of us. And if you listen to the recording, if you have problems, questions, I'm here for you. We'll figure out. Shoot me a text, and we'll make a little, group maybe, or individual, and just go through the things that are hard. What you don't want to do is you don't want to go like, let me not worry about it. and then later on it hits you in the butt and you still don't understand it, I'd rather have you come call me and we'll talk about it, or we connect you with somebody who knows the stuff already well and can explain it better than me. And then you have a good foundation for them to start. Because I don't know if some of you who've been in college before, my experience was in Carroll College. If I really get myself energized in the beginning of the semester and I'm, doing it and I don't just procrastinate until the midterm, that's one reason why I have a midterm for early on. Then I can sort of over time, it's like cruising through the semester much easier versus always playing catch up, because it builds on each other and you have to create. In anatomy, it's a framework of words, right? It's like, what is this term and how does this work? But it's all really inside your body. And so we want to have those things. For many of us, it's easier to learn those things when it's like normal language and not too technical language. And so we want to kind of approach it from, as many ends as we can with that. But this week, if chemistry is sort of like you have most of it in your blood vessels, and if not, you can always, and I suggest you do, go to the test review, because we're gonna have a test coming up. Is that our class? Yeah, that's our class. Test review. If you haven't done that yet, at least do it now. Make sure you understand these bullet points. Most of this stuff is check off because you understand it already, because we've gone through it a few times in the thing. If you want to print out, you print out, because that's here is what's on the test. So if you understand those points, you're good with the test. And the test is 55 questions. The first test is true, false, and multiple choice. The second test is going to be right in the blank. But I give you a whole list of terms, so you don't have to memorize all of that stuff. I'm not really big on memorization. And one reason clinically is when I went to chiro school, it's very funny, and the gist is, you don't want to look up an anatomy thing when you have a patient in your office, because the patient will think, well, you don't know what you're talking about. And I always get kind of irked by that a little bit, because I can ask a chiropractor, I asked, not all of them, but I mean, it's like when I asked the chiropractor, so how are you working the butts? How are you releasing the piriformis and muscle to make sure the pelvis is, no, I don't say butt, right? Make sure the pelvis is right and not hurting. And they're like, piriformis? I forgot where that muscle is. And it's like, dude, it's a major muscle. But I'm like, I'd rather have you look it up every time, and then after 3 times you know it, than ignore it and just not worry about it and say well, I guess that's not the problem with my patients or something. That's just kind of, and so I learned it when I learned a really specific muscle technique, and I have to go through the foot muscle detail and figure out where the attachment is on the bone and weird stuff. That it's really cool stuff if you're nerdy like me, but otherwise don't worry about it. But then I realized, it's like you have to look it up. And so it's much more like, how do I create a picture booklet for myself to look things up, to reference it easy and fast. And then I build a framework from that way, then have my attention be spent on, let me take this term and put it in my head. And then I have it for the test, because that's really not going to help the patient later on. I mean, if you go into nursing or so, everybody has their own path. But in terms of applicability, it's not really that great. So when you approach my studies, I don't really want you to focus on memorizing. I always want you to focus on organizing and integrating and understanding the material, because then you're going to be fine later on and you can build on it. And if you don't have an understanding, then you make sure you understand that, and then you move on, or make sure you don't just glance over it. If you so we always glance over a few little things, but if you can catch it, that'd be great, because the more you understand now, the better your whole studies are, especially if you go into medicine, because the foundation is anatomy and physiology. And then you go, so you learn what the things work when they work right, and then you go to the place what happens when they don't work right, and that's pathology. But if you don't know the beginning of the anatomy and physiology, you're going to run behind when it comes to those classes all the time. Anyway, there's my little 2 cents of Monday lecture on my pedestal. But anyway, go to that, because the test is coming up after this week. So I open the test, I think I usually open it from Friday to Tuesday. So I wanted to make sure Tuesdays to 12. Is that correct? Anybody? Yeah, it's open from the 8th to the 12th. And so make sure you put a little time on your schedule to, well, first to make sure you have all that stuff organized and understand all those points. Then you're cool to go. And then have, like an hour and a half or so, a good hour, to do that test, because this one you can only take once. This you can't repeat. So make sure you're aware of that. Not that, and I'm gonna make this 90 minutes. So we're gonna have enough time. So you don't have to worry about that. So that's 55 questions in 90 minutes. So you should be okay with that, I think, most of you. If that's an issue, shoot me a text. We'll work on it. If you have disability papers, I got some. Can you also, if you do, shoot me a text to make sure I catch that up? But usually 90 minutes is good for everybody. I don't have a problem, even if you don't have papers. It's like, I'm nervous with time anyway. Shoot me a text. I'll give you an extra slot. I'm not worried about that. I'm worried about that you do the work. I'm worried about that a test for me is sort of the final, going through the material that we worked through and have a final checking with it and saying like, this is, now I can put it into the corner and go to the next step. Because my tests are never cumulative in material. So they're always just what we're learning, and then you move on to the next. I don't expect my brain to know all this stuff from the beginning at the end. I expect my brain to be able to go back over it and then remember it. That's cool. That's why we have the book. Don't throw these away unless you think like it's weird stuff. But a lot of people keep these booklets as their actually foundation to then build on with the information and use it to an entry point to maybe a bigger atlas or a textbook or so. Anyway, but when I went to chiropractic school, that's partly why I made these books. I was reflecting on that. I never read a textbook because I fall asleep when I read textbook. I can't read these damn things. And so I always look at take really notes in the class and then be very diligent about that, make my flashcards with all of that info. And I assume, that's probably what I need to know. And then look at the books that, of course, I still had to buy, and look at the pictures and look at the caption and read that stuff and make sure I understand that stuff, because I'm very visual and kinesthetic. And then maybe look at the bolded words in the text and say like, hey, do I understand the bolded words? Or in some of the textbooks, actually, when I was teaching Bio 2, I used the outline in the back of the Martini book chapter as my teaching guide, because it has all the relevant stuff in it. And if you understand that, you understand the text basically. And if you don't understand, then you go look in the text and learn and research it sort of. So that's how so I'm just telling you that if you have a hard time reading textbooks, you're not alone. So just don't feel too, because I always felt bad about that. And then at some point, the head of the department a long time ago, a really cool guy, very, very good professor. He's responsible for a lot of good stuff at Merritt. He said, he has to use all these colors to highlight the text and things to organize the material in a book and stuff. And I'm like, even people with a PhD have to do that. So I was like, you do all that you can take from learning how your brain works to absorb and process material and utilize those tools and use this class maybe to bounce a few ideas up back and forth, because I'm here for that. I've been thinking about this stuff for 20, 30 years. Anywho, any questions to this little spiel?
Yeah, I have a question.
All right, go for it.
So somebody asked a question about what is it? Strong and weak. Oh, buffers. And I'm like, I don't really understand that either. And I'm trying to think of like a real life experience. So are antacids like buffers when our stomach is upset? How?
Yes,
okay, explain to me that.
Well, so it's a bicarbonate ion, right? And the bicarbonate can pick up a hydrogen ion that's free floating. And the hydrogen ion concentration, the free floating hydrogen ions in the solution, is what creates the acidity. So the more hydrogen ion you have free floating in a solution, the more acidic the solution is. And if you throw bicarbonate into that solution, it basically acts like a sponge and soaks up the hydrogen ions by making carbonic acid out of it.
Okay.
And so by that process, it absorbs a hydrogen ion. And then that makes the solution less acidic. So it acts as a balancer in a solution because it can pick up and let go of hydrogen ions.
So are there natural foods that people can take when their stomach is upset besides an antacid pill?
Oh, I'm sure. I just need to look it up.
Oh, okay. Yeah, no, my
No,
husband,
that's a good question because it's hard because it's one of those medications that I have some patients. They are on the stuff for years because they had one episode and nobody ever takes them off of it.
yeah, that's my
And
husband,
so
and I don't think
and
it's a good thing.
and no, because you're decreasing digestion if you're decreasing acidity in the stomach. It's just you don't want it getting kicked back into your esophagus. That gives you heartburn. But who says you got to eat chili all day long? I mean, we also have to adapt a little, right? That's when I see these commercials and it's like, you want to keep eating the hot flaming pizza, and I'm like, well, I can't do that. I'm 53. Why should I have to keep doing that and then eat my antacid? Maybe I should adapt and not do it. And be good with the fact that I have 50 years to be able to do it. It's like, we got to think about these things. But when I look at natural antacid remedies, there's a picture right here, for example: cold milk, gooseberries, fennel seeds, buttermilk, bananas, pineapple
Bananas.
juice.
Okay, bananas.
Banana is interesting, and pineapple is good for a whole bunch of stuff because it's got this. No, papaya is actually, that's one of the, but pineapple also has a lot of enzymes in it. And mint makes sense. Mint's actually one of the essential oil type things that's studied, and it's studied for helping stomach problems.
Oh,
and then look at that garlic and ginger.
Oh,
I'm not so
ginger.
sure, but
Okay, ginger.
yeah. So those are some that just come up in the picture here,
Okay,
which
thank you.
take a copy the image and put it in the chat, maybe, if I know how to do that. I've never done that. Oh, well, oh,
That's okay. I can
the
Google.
URL.
Oh, okay.
Paste. Let's see. Nah, that's the URL. Well, if you click on that, you get to that picture. So
Okay,
it's
thank
just
you.
the first one that looked kind of funny. Anyway, that's that. Any other questions? That very good question. I'm glad you make me think, because it's hard to think sometimes. But if you don't, or if you don't, then we go right to. Oh, look, this is, well, never mind. Then we go right to this week. So this week is week 3. This week we're gonna do cells, and this week we're gonna do tissues. So that's cells kind of make sense, right? It makes sense. Cells are the smallest things that crawl around on the, that are like but that are basically the smallest unit of life, is how we should really start and explain it. Are you guys familiar with cells?
Yep.
Good.
My
So
degree's
we'll
in
go with cells.
microbiology, so I can relate to
There you
that.
go. That's that kind of stuff. That's like so basically the cell is the smallest thing that can live independently without any other thing. Well, you need stuff from what we learned in chapter 1, like the environmental stuff and the new food and energy and stuff like that. But a cell we can study as a unit of life, a fundamental unit of life that contains anything in it that is needed to sustain life. And so when we look at the basic structure we have all these different structures in them. They call them organelles because I guess they're little organs. That's why they call them organelles. And like you have some, like this is mitochondria, and that, for example, creates energy. So when we talked about ATP in the last chapter, this is where we make that ATP. Or we have, these are cool too, lysosomes, and the term LIYS means destroy, kill, that kind of stuff. And so these are things that have hydrogen peroxide in it, and as we pour it on a wound, they pour it on stuff that we don't want in the cell, and that kills the stuff that we don't want in the cell. We have here we have a nucleus. You guys know DNA, right? That's also talked about last chapter. That stuff is in here. In the nucleus, and look, we even has a nucleolus. It's a small nucleus inside the nucleus. Gets a little complicated. And so we have all these little things. These red dots are where we make protein, for example. And so in this chapter, what we're going to do mainly is we're going to talk about these organelles. And then we go a little bit into the DNA material, a little bit, not really deep, because I'm not really a geneticist person. And it's not the purpose of this class. This is a separate class on its own. It's interesting stuff. It's just, I'm more into lifestyle adaptation than genetics. And then from there, though, we go into the RNA. And RNA at this point is a very understood topic since we had COVID around and the vaccines. And holy cow. On a Sunday, I went to the farmer's market and now we're really starting to have these conversations. This guy was thinking everything is communism and was starting to scream around on the farmer's market. Like, you got to be quiet a little bit. So RNA, you know, the vaccine thing, he was having a fit about the vaccine. We don't have to worry about talking about it. But I want you to understand it because RNA is what DNA is what the hereditary material is inside the nucleus, and RNA is a copy that we make of a part of that material to then go and make protein. And so that's sort of the process. And that's one other thing that we learn in this chapter, besides the organelles, is how to make protein. And that's a process of making that copy, making that RNA, and then from taking that RNA, which is sort of like a cookbook thing to make protein. That's what actually DNA is, actually a cookbook to make protein. That's really what it is. It's not a brain. It's just a cookbook. Because it's interesting when you look at the cell, a lot of the communication of a cell to cell is on the cell surface. It's not inside the cookbook. It's not what we sort of generically think that the DNA is sort of the brain. I went to school in Cairo, and Bruce Lipton is a Stanford guy, and he's really big now if you look him up. And he was one of our teachers, and he is big in that cell-to-cell communication. And he was talking about, and we bring that topic up when we talk about fat. Oh, did we already talk about that? The HDL and LDL kind of stuff, and the trans, and how it stiffens the cell membrane and doesn't make it fluid, and how that stiffens communication. And then that's how, for example, one of the explanations of why these things are so bad, because it makes all the stuff stiff in the brain, or, you know, where we want to talk to cell, and it can't because it's too stiff. So that's like weird, interesting kind of food for thought that brings these, you know, chemical stuff onto almost a structural level. And if you actually watch in this chapter, one of the on the back of the booklets, there is these little videos. And this chapter, that one that I like the most, we already watched The Kill Creativity, but there's one of them that's about animation, and where the heck, I have to find it. And so it's Drew Brees is his name, and he animates the second process that we're actually going to talk about in this chapter, which is cell division. And he animates when the cells divide, and these are the chromosomes, these are the genetic materials. Because if you actually look at cell division, the most important thing is really that you need to copy the nucleus, because that's the material that has the cookbook. I mean, that is the most important material from that perspective, because if you destroy the cookbook, what are you going to do with that? You can't make protein anymore. And like enzymes are proteins, so that's like going to be a big problem. And so that's why, you know, the cookbook gets all that attention, obviously. But the expression of the cookbook, that's a discussion that we can have. But when you do cell-to-cell division, that means you make two cells from one cell. That's really what it means in the cellular world. And so what you need to do for sure is you need to copy that genetic material. And that genetic material is in here on this slide, and then gets into these red things that line up on these strands, and are very well organized. That then when we are starting to split the cell, which we basically do, we make from one, we make into two. We call it from a mother, or we make two daughter cells out of a single cell. That's the language they use. But we need to make sure that both cells are going to have the equal set of these genetic materials in them. And so they are lined up and organized and then pulled to each side by these strands. And that's basically what cell division is. And then we got all these terminology around it: prophase, metaphase, anaphase, and telophase. And you learn those, but essentially it's sort of arbitrary, a process that we need to describe, and that's why we make names out of it. And so that's the second process. I'm still looking for that darn video. Hold on. Oh, animations of unseen biology. The bottom one, the middle. It's 10 minutes. Watch that when you get to that part of the chapter, because it's really visualizing how it's physically mechanical, like structures with legs and feet hold these red things and pull them to one side of the cell, that then on the other side of the cell, to make sure that they're all distributed equally. Very interesting stuff. And so that, I think, is very helpful, because one of the things that we talk, we process that in the last sort of chapters, study tools and stuff. I think videos, especially with YouTube, please, if you got a good video, ship me the video over so I can put it in the resources more and more and start building the resources up, because videos are just so fantastic, and YouTube is grandiose how easily we can access these things. And that's where that rabbit hole algorithm is actually helpful, because you're gonna get deeper and deeper, and at some point you find a video that really speaks to you as how they visualize certain processes, and then you follow that channel and keep looking at that. So that's, I think, something that if you are a visual person, please, take advantage of the great times we have. We probably got some old people in here like me, that's the textbook reading, and it's like falling asleep. It's like, it's so much nicer now. It's so exciting to be in school right now, I think. Anyway, but of course, as a teacher, I got to say that, right? So that's I think, pretty much the cellular transport is the last part of that chapter, because we have to move things around in the body, and we transport things in and out of the cell. That's a big one, because one of the big things about a cell is it's a membrane. It's a really interesting structure, the cell membrane, the boundary around the cell. And it's like buoys that you sometimes see in the water, like that float and create a barrier. And it's like floating and creating an oil barrier, because what a cell membrane really is, as we learn in chemistry, it's a trapped oil film within hydrophilic molecules. Hydrophilic, they love water. So on each side of the oil film, you got water loving stuff, so you can be in a water environment. But you have an oil film that sort of goes and is separating that one side from the other side of the liquid, and that cannot be crossed by things that are not oily things, watery things, like a lot of carbohydrate food particles and things, not the oily stuff, not the fats. The fats can cross over easy because they can cross through oil, but the carbs, they get repelled by that. You see that in a salad dressing. You have to shake it, but even if you shake it, it's going to separate out again. It's that sort of process. So hydrophobic, hydrophilic is a very important concept to understand, and I should probably have a question on that. So if you don't, please reach out to me. Because when it comes to cellular transport, a lot of it has to do with that boundary that things cannot just cross. And so we have two types of transport. We have some transport that is called passive, and some transport that is called active. And the difference is that the passive transport happens automatically, and the active transport takes energy for it to happen. I visualize that like, Merritt is on top of a hill. So if I have to get with my bike on top of the hill, that's active. That's a very active pedaling. If I'm on top of the hill and I go down, I don't have to do nothing except make sure I don't fall into the tree and steer the vehicle, because it's a steep hill. And so that would be passive. I don't have any energy expenditure. In chemistry terminology and cellular type stuff, what that means is an active transport. What we use, actually, instead of a hill, we use concentration. So we use how many of the particles are on, let's say, one side of a boundary, which in oil film is a boundary for hydrophilic things, or things that cannot penetrate the oil, and then how many of those particles are on the other side. And so if there's many more on one side and hardly any on the other side, that's a big difference in concentration on one side than the other side, and concentration of those particles. And so some particles, like you put a sugar cube in a tea, slowly over time, those just diffuse out. Maybe you got to shake it a little bit, but basically those particles freely go through the water of the tea and want to diffuse and equal out and be equally distributed through the whole solution. So that's great. That's a passive process. You don't have to do anything really. You don't have to use ATP for any of that. And then we got a few other ones that come in passive format. And one of those is, for example, if you have a protein channel that either lets molecules in or doesn't let molecules in, and it tells you if it does or not. It just isn't always open and lets everything in and out, kind of thing. Then that's called facilitated. So you can actually open and close. You can control things with that. So that's pretty cool. Because when we need to really think about active and passive processes is when we think about, let's say a nerve impulse. A nerve impulse needs to go really fast. And if you use ATP, that's great. You can move things around, but not that fast. If you're going to pedal up the hill much slower than you're going to ride down the hill. And it's the same thing with that. So if you have something where we really need a passive process that goes fast, or a fast process, we're going to establish a situation and then use a passive transportation sort of vehicle to create that quick response. Like in a nerve impulse, is you push sodiums to one side of the cell membrane and potassiums to the other side. We'll talk about that later. And then all you got to do is open channels at the right time, and things flow in and things flow out real fast. And that's your nerve impulse. And so that's actually, using wise, one of the reasons, why we need to have these passive processes, and they're very, very important. And then the other one we have is osmosis. That's also a passive process. And that's I don't know if you guys understood that real well. Oh, no, we're going to do that. Sorry. And that's, instead of molecules moving, now you use water and you move the water. So you have a membrane in between, let's say a beaker or so, that cannot move the molecules around, just a liquid. And that the particles, so to speak, suck the liquid to the area where the concentration of the molecules is greater, and wants to have the liquid, the water, the solution equally distributed between the two sides. Wants the concentration of the little particles equal inside the solution, but it doesn't move the particles because it can't, so it moves the water. So you can use that in the body. For example, if you think about the blood gets distributed through the body, the heart pumps the blood through the whole body after it's been, soaked up with oxygen. And then in the tissues, a lot of the blood needs to seep out into the tissues and give the tissue the oxygen. Well, how the hell is that thing going to come back into the blood vessel and then go back to the heart? So what you do, or what the body does, one of the things it does, it keeps certain larger molecules, the albumin, a protein, inside the blood vessel. And then after the tissue seeps out, and the blood seeps out, the liquid seeps out into the tissues and needs to be picked back up. Part of the process it does that is by the soaking up of that albumin back the fluid, and wants to bring it back into the blood vessel. And so that's a really used place where we use osmosis. The other place where you can see osmosis, sort of like in your kitchen, is you slice a tomato and put a little salt on top, and after a little while the salt is not there anymore, but you got a drop of water there. And so that's where you can see how salt pulls out the liquid. That's osmosis at work, basically. All right, so anyway, I should shut up. Damn, sorry, I'm going a little overtime here. Are you guys all right? Hello.
Yeah, we're cool.
All right. Are you learning anything, or is this just like, what the hell is he talking about? 50-50? All right, we can live with that. So the only other thing that I will talk about this, is then the active transport, and that's where we need energy to really move things in and out of the cell. Some of that is small stuff like ions, which are these particles that we use, for example, in a nerve impulse. And those have to be pushed in and out of the cell against the concentration gradient. It's like you're pushing. I used to use the picture, I think still do somewhere, I think in the Japanese metro in Tokyo, where they push people into the metro and then close the door, and they have to. And then you have all these people in the metro thing, and then it opens at the next station, everybody falls out. And so that's kind of like what I visualize this process sort of with a little bit, with this concentration gradient. And then the other one where we have to talk about, or you will talk about a little bit, is larger particles going in and out of the cell, and we calling that endo and exocytosis. And you'll get to these terms when we get to that. All right, but that's it for this chapter. So it's actually not. It's getting more palpable, it's getting a little easier to grasp than a chemistry chapter for most of us. And when we go to the tissue chapter, it actually starts getting even more into that palpable department. It's just, what are tissues, And so that's where I always was stuck when I learned this stuff at first. What are tissues? And we got 4 tissues, and one is epithelial, one is connective. And then the third one is muscle. Muscle's fine. Muscle's right here, the thing that contracts. So that we'll talk about that when we get to the muscles. And then the other one is nerve, and we'll talk about that when we get to the nerves. And so those are very specific. And then we have these 2 tissues that sort of make up everything else in the body. And one is called epithelial, and the other one is called connective tissue. And the epithelial tissue, I think I like to sort of understand first, and look at its function. Then where do I find that? Well, another reason why I have a hard time with this chapter in the beginning of the book is like, where do I find all these tissues? But I haven't talked about these organs, and so I'm not going to give you a list where everything is located, and you just go like, what? Where? Well, at the end it makes sense. But if you know what the purpose of each tissue sort of is and what the function is, then we can plug it in as we get through the process, through the semester. But when you look at where you're finding, generally speaking, epithelial tissue, you're finding them on things where you need to cover or you need to protect. So you think of like the skin, for example, where you be able to bump into things and you don't just bleed out. So that's protection, right? I mean, we have to think fundamentally, it's often of like, well, why am I not just dying every moment? It's like, oh, because I can bump into the wall and I don't bleed. Because my epithelial tissue protects me. So covering things. And then another thing an epithelial tissue does, it lines tubes on the inside. So it covers and it lines tubes. So on the gut, for example, it lines the gut tube, the stomach tube. And so one of the functions it does, it absorbs nutrients. So that's another function that epithelial does. And then it also works on being part of glands. So when you're sweating, your epithelial cells are working. And it's part of the seeing apparatus. And so if you then, you retro sort of engineer, okay, these are the functions. Where would I find that? And then as we get through it, you start plugging it in. And the epithelial is pretty simple from that perspective. Because then when you look at the cells, you got multiple cell types. You got flat cells, and they're very good to diffuse things like air because they're like paper thin, think physically. Then you got cuboid cells, and those are good for sort of less abrasive stuff, a little thicker. So you have like liquid, like in the kidneys, for example, you find those. And then you get column-shaped cells that are long, and you're thinking, oh, well, they're a little longer. So maybe the part of that is the abrasion. So it's like more food, I tell you. That's part of why they're cuboid shaped. So they're a little bit more withstanding friction. And so that's where we find those, where the food sort of moves through the body, a little more the gut too. And then, so those are sort of the main cell types. So it's just 3 of them that we sort of go. And then the tissue comes either in a single layer or in multiple layers. And the difference between that is multiple layers generally is more protective, and the single layer is more like absorptive. You think about things go through this easier than through this. If you have to think of a gas exchanging, like an oxygen moving through, or a particle like a carbohydrate. How the heck are you going to bring a carbohydrate into the bloodstream from the stomach? Because you got to get through these cells. And so look at this a little bit from that perspective. And I try to teach it from that perspective, where it's not just a laundry list, but it's an understanding of what is what, and then we can plug it in over time. And if you have a problem, you text me, and I'll be there to study with you a little bit. And then the other tissue type is everything else. So we got muscle, we got nerve, we got this epithelial thing covering and tubes, and now we got everything else, and that's called connective tissue. And there you want to learn that the connective tissue has multiple. And when I say everything else, I'm saying it's bone and it's blood. I mean, it's like, what? How are those two related? And somehow embryologically and how we were built and all that, or maybe just because humans need to categorize. And so that's why we put it all in there. But what's really for us important is when we study is it has multiple layers of multiple components, and one component is cell. Where in epithelial, all I talk about cell, because it's actually only cells. It doesn't have other stuff. So connective tissue has other stuff. So it has cells, it has fiber, and it has what's known as ground substance. And together, fiber and ground substance made up the extracellular matrix. And if you're in the orthopedic world or surgical world, you probably heard of ECM matrix. And that's what that is. That helps healing because it helps the connective tissue heal. And so when you're learning these tissues, then you're learning, well, what are the cells that are part of like blood, for example, or bone, for example. And then you ask, what are the fiber types? You have a few fiber types. You have collagen. We know collagen, right? That's sort of like, things that strengthen tissue, that glue. It's a super glue in the body. A lot of more modern pathologies have to do with collagen weakness to some level. Or no, that's one of the categories that I find. And some of that has to do with, poor nutrition and overall sort of problems and all of that over time. And then we have elastic fiber and we have reticular fiber. So we'll go through the three fiber types, and then we go talk about the ground substance, but that can be calcium, bone stuff, or that could be water in the blood. So that's many, many things. And so we talk a little bit about that in this chapter. And then we apply those to cartilage and to bone, because the next chapter is going to be bone, and then we get into muscle, and cartilage and bone go together. So that's sort of the segue into then the bones, and the next week we're going to do the skull. All right. Any questions to that?
No.
Good. If anything come up, just speak in. And then we have a little questions around it, and then we talk a little bit about, we have an understanding. I just want you to be explaining the mitosis and protein synthesis in your own words. I think that is a brief discussion of like a little bit, hey, how was this food label thing for you? Boring, good, interesting, not? What was it? And then this is sort of the big one this week, where I want you to, this is a pandemic leftover that's really helped a lot of people, and I think it's cool when we make it physical. But I mean, this is kindergarten stuff, but it's really cool because you can do it with your kids if you have kids. But I want you to find household items of food stuff or things that you find that resemble the different organelles. There's a list of them somewhere in here. Yeah, here, see the organelles, these parts. And then I want you to make your own cell that way, sort of as a construction, and make a ledger and tell me what the different organelles do. And so that's sort of, and I think that's in the discussion forum. So then you relate back and forth a little, and just have a little involvement with each other on that, because the more time we spend on these things and sort of talk about them and maybe even make it fun to some level, the easier it gets into the brain and the more it seeps in. So that's one of those exercises. It's not really a health kit thing, but it's one of those kinestesizing exercises, or kindergartification. Actually, I use that term, and people think that some of the other teacher thinks, or the dean thinks that's really funny and really useful, actually, which is interesting. And then we stop with the Quizlet thing, and so we don't have too many extra activities in this week, because at the end of the week we start having the test. And so make sure you do that and don't miss the 12th deadline. It's still after next week, after next Monday. So I'm still going to be able to tell you about it or encourage you to do it. But we will start next week. We will start looking into the skull and into the facial muscles, and then after that, we will go into the in-person sessions where they're not mandatory. They're they're optional. I call them optional in-person sessions because I want you to be able to be exposed to the muscles and the bones a little bit more hands-on if you feel like that helps. And then later on, we do a few dissections in the classroom. But again, you're not losing points if you don't, but you're winning. You can win points if you come. You can get extra credit points in the dissections. But it's very useful for the ones who can to be in person at times, because palpation and tactile and talking with each other about it is just kind of helpful. And so we're doing those starting not next week, but then the following week on Monday at night and the evening 6 to 8. And I make videos of the relevant stuff. So if you can't come, then you have videos. So don't worry about that too much. I just want to start introducing that, and we started doing it that way because it's not obligatory, because some people are, COVID is still around and it's hit some of us harder than others, and we want to be sensitive to everything. And so that's why it's sort of up to you for those parts. But also you need to know that some schools do require, like UCB, I think, if you want to transfer, that some of those classes do have those physical components in person. And so make sure you don't, miss that opportunity if that's the case with you. Anyway, that's all I wanted to say about that. We'll shoot you some text on those things later on. It's not just yet. It's coming up. But having said that, that's it. What I have to share this week. Any questions, any comments, any concerns? Hello, can't hear you. No? Well,
No
then we're
questions.
good. All right, then I'm good on my end. Thank you guys for sticking around and coming, even though it's a holiday. Hopefully, it should be an okay week. All right. Thank you. Have a wonderful week. Enjoy. Speak up and come to text me if you have anything so we can meet. Bye.